Alright, CrewDunnerMoansHouseOfMath.com, goofing around with various types of screencasting software. This one gives me 15 minutes, so I can do a nice presentation on completing the square without being rushed for time and without having to do it 3 times, because the other screencasting software I had only gets you to do 5 minutes at a time. And I think for $9, the pro version of this lets you go for an hour. So I have all kinds of ideas, because I could do 5 or 10 minutes, and that's obviously not enough. You guys want a whole hour of lessons using these blocks, then, you know, $5, or I don't know, $19, depends on what the topic is. But, you know, a few dollars, and you get to watch the whole video. Otherwise, you just get a 15-minute synopsis. Alright, so here is going to be the 15-minute synopsis, because I haven't made a full hour on completing the square, but gee, it would be pretty easy to do so. Let's take a look. Here is x squared, 2x, and 1. And this is the first time you've seen this. I would recommend you go to CrewDunnerMoansHouseOfMath.com or my blog spot and fool around a little bit to get comfortable with what's happening before you look at this, because we have x squared, 2x, and 1. We can do a quick 3-period lesson. This is x squared. This is 2x. This is a unit. So here's the symbol for x squared. There's 2. And what kind? Oh, x. And here's 1, just units. Okay, we could do a 3-period lesson on that, but I'm not going to spend the time. It takes too long. Let's just quickly take this and turn it into a rectangle. And not any kind of rectangle, a square. Alright, so the student was able to do so very easily. There it is. And now all we have to do is count the sides. Super easy. And you can see she wrote down here x plus 1, x plus 1. Now we talk about economy of symbol. And with economy of symbol, I just mean fewest symbols possible to get a point across. Why do we have to write it twice when we can just put a 2 there? Further explanation on that, right? No concept is beyond the child's grasp if it's presented at the child's level. See, why do we call this an x square, or x to the second power? Well, it's x this way, right here, x this way, and it's x this way. So we have x times x to the second power, right? So we just write x2 there. So here's just x plus some more, 2 ways. So we write it that way. Very simple. And skip over that. Now, here's a typical problem out of a textbook, using completing the square to solve this. Well, we don't like this problem particularly because it's not easy. Let's put it that way. If you're going to start, don't start here. Even though it looks simple, teachers, don't start here. Start with one that works out perfectly so you can get the understanding. And you'll see what I mean. Bear with me as we go along here. But we can still fool around with the concept. What we're going to do here is, there's no way to factor this, because 1 won't fit in the corner. In other words, I can't make a nice rectangle or a square using 1. So hero 0 comes to our rescue. We're going to get rid of that 1. And now I just have x squared and 4x. What completes the square? Well, any little kid can see this. And we can do a whole lesson on problem solving, how it is that -1 winds up over here. Right? But basically it's just hero 0 again. If I subtract 1 from this side, I subtract 1 from this side. The student I was working with understood this concept. I didn't have to belabor the point. But some people, they'll say crazy things like, when 1 walks across the equal sign, it turns negative. No. What we've got here is hero 0. And hero 0 is the same thing as 1 minus 1. Isn't 1 minus 1 0? Well, if I find same stuff, and that's what this sign means, right, equals same, if I find same stuff on both sides, and I take away a 1 from this side, and a 1 from this side, what's left is -1. Go check out my problem solving page for more on that. Okay, so now she can easily see, to make a rectangle out of this, what do? Cut those 2 in half, and oh, yep, easy, right? Okay, so I don't give her rules about what to do here. She can see that what you have to do here is cut it in half and make a space for a square, which is why we call it completing the square. I've had arguments with college professors that tell me that it has nothing to do with it. It's like it's a neat name for this problem. It's not a neat name. We are actually dealing with squares. Okay, it blows my mind. It's true. And more than one college campus in the United States that I've been to where we've had this discussion. Because they get so caught up in the symbols, they forgot all about the symbols relating to physical reality. And we can take these symbols and graph them, but they also have geometric reality that they relate to. right? These geometric forms. Really, when they were first doing algebra, this is what they were fooling around with. They were drawing in the sand. They weren't just using symbols. Okay, so now I see that I've added 4 here, and I've added 4 here. And we can really see this is 4 and a negative 1. And over here, I had my x squared and 4x, and I added 4 more to complete the square. So keeping up with the symbols, because we won't always keep up with the symbols as we go forward. There it is, right? Okay, and here we have economy of symbol again. We didn't have to write x plus 2 twice. We just put it there. And that's the same thing as a 3. Ooh, this is why I say we don't want to start here. Even though for you people that are familiar with algebra, you know that it's very simple to just square root both sides and then solve. You don't want to start here because you don't get the understanding when you're talking about square numbers. Somehow when you put that square root sign in, a lot of understanding gets lost. But I did one quick thing here for another student that I know will be watching this. Oh, what form is this? You see anything about vertex here? Yeah, okay. H and K, so on. Alright, so now here's a problem that's great to start off with because it's going to work out to be a perfect square over here. And I, of course, picked -7 so that it works out nicely. And again, not to belabor the point, over here, hero 0 is 7 minus 7. Right? 7 minus 7 is 0, and there's a -7 here. There's a -7 over there. So when we add, what she likes to do is add a 7. That's how we get it. Right? Hero 0. Make this into a 0 by adding 7, and she understands that you have to add 7 over here. But the other way to look at it is by having these blocks over here and taking away the negatives and a negative here, what remains is a 7. And like I said, go to the problem solving page if that's confusing, which it shouldn't be. But oh, boom, done. Look, super easy to make a square, right? What are we going to have to add to complete the square? We're going to have to add 9. So let's get our symbols going. So first, that's what we did. We added 7 to both sides, one way to look at it, which left us with nothing there. Completed the square with a 9, so we had to add 9 over here. See how that works? And this time she forgot and wrote them twice, but we used economy of symbol to get that. And you can see that we have x plus 3 squared is the same thing as 16. Did a quick little refresher on why it's this, right? Because if x times x is x squared, then this is just x and some more squared, right? Okay. And then we can easily see that, oh, that's 16 there. And look, a 16 is a square, and this is a square. Once again, we form rectangles to facilitate the counting. And we have a square equal to a square. And now it's very easy to see what the answer was going to be there. She knew what the answer was. That we just had to add 1. So now we're going to take it to the next step on the next problem. Here's the same thing. Same every time, right? Completed the square. Didn't even take all the pictures as she did it. Completed the square with 16, right? Taking half of that, put it here, put it there, half there, half there. Complete it with 16. See, it starts to go fast and easy. And now we have 25. And now there's the symbols for it, right? We completed the square with 16. Added the 16 to the 9, which we had already moved over here. Okay. And then we have that. And now the next thing to do is try to figure out what x is. We factor it to make it super easy. And now she can really see, like over here, you can't see that x would be 1 easily. But over here, it's super easy to see 5 plus 1 squared is 25. But even more than that, we're going to use problem solving very quickly to solve that, using the square root signs I talked about, right? So we square root that. Now I just have a 5 and an x plus 4. Now it's super easy to see that x is tricking you, trying to make you think it's big, but actually it's just a 1. Simple, right? Oh, there it is. And we can see x is 1. Okay, so the last one, we have x squared 10x minus 11. Alright, isn't it great? Look, I can go over 10 minutes now. I still have almost 5 minutes left to get the point across. Do you see very easily I can take these, and I did this just for the fun of it, and it worked out very nicely. Okay, I move it over. See, we're just using we're not keeping up with the symbols, we're just playing with the blocks, but understanding that later on we can describe what we did using symbols, so we can remember what we did. Right? If we just see the symbols on the paper, rather than having to draw crazy pictures and so forth, because the symbols really are faster, and that's why you want to move to the symbols. So again, take half, put them on top, take half, put them on the side. What's going to complete the square? 25. Right? And then there's a little lesson on hero 0 again, the way she likes to do it. Right? If we add 11 here, then we have to add 11 here. But really, there is a negative 11 hiding over here. We talked about that a little bit. Okay. But really, 5 basic concepts, doesn't matter what we're doing. Now, we have the x squared plus 10x equal to 11. So what's going to complete the square? 25. Very simple. You can see that. So we add 25 to both sides. And now we have x plus 5 squared equals 36. And when x plus 5 squared equals 36, and see, very cool, made a rectangle out of, or excuse me, not just a rectangle, a square out of the blocks we had just by putting that 6 there. See, and it says 6 square. There's my 25 that I added, and there, right? And the extra 5 and the, right? So there's my 11 that I added to my 25 square. Anyway, it worked out quite nicely to make a square. And we can see that this whole thing is the same thing as this whole thing, and now all we have to do is to solve for x again, right? And again, made it super easy before we get to more complex problems, right? Where we didn't even, you'll see some eraser marks here, where I square root that side and get x plus 5. I square root this side and get 6. Didn't even put the symbols in. Well, I mean, we erased the symbols actually and made it nice for you to see. And that was it. Done. We didn't finish the solving, but we're solving for it. We just got to this point and understood that, look, 5 plus 1 equals 6. Or, excuse me, 1 plus 5 equals 6, right? And the way we'd solve that, we would take 5 from this side, take 5 from this side, there'd be 1 left there. X equals 1, just like we did a second ago, right? And see, that's why I want you to understand the math needs to be consistent for these children. Here, or your students, can't be magic. Here, there's a 4 hiding in here. Just like I was saying before, when we had the negative numbers with 0, there's a negative number hiding in 0. But here, I just have 4 hiding in there. And it's very easy for the kid to see. I mean, little kids can do this. They don't have to be in high school. I have 6, 7, 8-year-old kids that are doing completing the square things like this. Really. And now you can see why. See, and they get the concept. And even if they never see it again, they come to me and they never see it. When they get to high school and they see these problems, like, oh, it's familiar, it's in there, it's in their subconscious, it's back in their memory someplace. It's not completely foreign and new and difficult and scary, right? Completing the square, hugely important in mathematics. I can't even emphasize it enough. It's going to show up in elementary calculus. It's going to show up in statistics. It's going to show up in pre-calculus. It's going to show up all over the place as a way to do problem solving. Now, this is the very basic elementary completing the square that I've shown you here, right? But the concept is there, what you do, what has to happen. And then the next thing that we do, of course, is talk about how we can do it for, finding the vertex and so forth, and, having the HK form here, and how we get to that. Oh, this is just a factoring problem we did, and how we get to that. And then what happens if I had, say, 2 times the number, or 2x squared, or 3x squared? How do we go about converting this into the standard form for vertex, where we can, still do this, and then have like a coefficient out here. And you'll see that in pre-calc and so on. But for now, we just keep it super simple and easy and understand the basic concepts, and then we can build on this. Anyway, CroutonRamon'sHouseOfMath.com for more.